Hello YouTube, welcome back to my channel. So in today's tutorial, we're going to go over the random forest classification algorithm. So in the last tutorial, we looked at a decision tree and we discussed what a decision tree is and as a classification algorithm for machine learning, right? So into the end, we are able to draw something, come up with a decision tree like this, and then we're able to build a model to classify data using a decision tree, right? So the difference between a decision tree and a random forest, they're very related things, right? So a decision tree, you can just think of it like a normal tree, just a single tree, right? And then a random forest, just by the term forest, right? The forest consists of many trees, right? So a random forest is just an algorithm consisting of many decision trees, right? So decision tree is just a single tree, while a random forest is just a collection of those multiple decision trees. That's what a random forest is. So that's just basically the difference between the two. So instead of having just a single decision tree, we're going to have multiple decision tree, and it is called a random forest, right? Forest has multiple trees. So that's all. So now let's look at how we can build a decision tree algorithm. So the first thing that we need to do, how we can build a random forest algorithm. The first thing we need to do is need to bootstrap our data, like randomly select data samples to form our own data set. After that, we need to randomly select columns or variables from our data set. The reason why we are doing that is that we don't want all the decision trees looking the same. I'll explain to you just shortly what I mean by that. After selecting the random variables, we construct a decision tree based on each selection for random variables. After that, we train the decision tree using the data that we got through bootstrapping, and then we repeat step from the first step to the third step, changing the columns. Okay, we do this until we get the number of trees that we want, and in the algorithm you can specify how many trees that it is that you want. Okay, so now just imagine that we have this data set. This is a data set that we'll be using. We'll be classifying if a person will get a heart disease or won't get a heart disease. So we'll be using this data set in today's tutorial. So let's imagine that we want to build a random forest for this, right? We need to build multiple decision trees. So the first thing is that we select we bootstrap our data. This will be done for us in the background, and then after doing that, we need to select random columns. Okay, so it is also be done in the background. For example, this example, we take age, the sex, the CP, the treasure, blood pressure, the cholesterol, just these four, right? And then we build a decision tree. Let's say the decision tree looks like this, and then we go ahead and train that decision tree, and then we come ahead and select the FPS, the old peak, the slope, and then these other things, and then we train our decision tree, and then we have another decision tree like this, and then we come back and we select other random columns, maybe the slope and the sex and then the age. We train another decision tree. That decision tree will look like this. So we do this until we have the number of desired decision trees that we want, and we train all the decision trees using the same data set. So after doing that, we'll have multiple decision trees. So how do we make predictions? So to make predictions, we pass, if we take a data that we want to predict, we pass it through all our decision trees, right? And then we store their results. From there, we select the result which is the most frequently occurring result. For example, if most of the trees predict that let's say we pass this through our random forest, right? And this tree predicted that let's assume that this tree predicted that a person will get heart disease, and this predicted the person will get heart disease, and this tree said no, the person won't get a heart disease. So we store that result, all the result, and then later we do what is known as bagging. We aggregate the results. So the ones that said the person will have heart disease is more than the ones that the trees that say the person won't have heart disease. So we'll classify that data as a data point, as a person, a person or individual who is going to get a heart disease, right? So that's how we are able to make prediction. This process is called bagging. So yeah, so that's how we can go ahead and build a random forest. So why do we need a random forest? Why should I use a random forest over a decision tree? So the reason why you use a random forest over a decision tree is that a random forest is much more flexible compared to a decision tree. Think of it like multiple experts making from the same field, but with different variations of knowledge, but making decisions on the same concept or on the same point. Having multiple experts is better than having one expert, right? So that's just the concept of a random forest. It's much more flexible, and unlike a decision tree that does well in training and does well when predicting unseen data, a random forest is much more flexible and gives you better predictions. Okay, so that's why you use a random forest over a decision tree. So now that we have looked at that, let's go ahead and load our data set. So I've simply imported pandas as PD, and I've loaded this data set. This data set to be found in the link in the description on my GitHub page. You can find this data set. So I've simply loaded in the data set, and then this is what the data set is. So let's go ahead and split this data. I've already checked it. It doesn't have it's a very clean data set. It doesn't have a much outlier, so we won't do any feature engineering or data cleaning. It's quite a clean data set. So let's go ahead and actually to split our data into training and setting and training, sorry, the x and the y variable. Okay, so we're going to, from Sklearn, by now I think we should be used to this. So from Sklearn dot matrix sorry dot this is a model underscore selection. Let me check it. Displaying selection, you're going to be importing this is actually train underscore test underscore split. Okay, we're going to import the train test split, and we're going to go x will just be train, sorry, x, my bad. So this will be x underscore train, and then x underscore test, and then we're going to have y underscore train, and also we're going to have the y underscore test, or be equals to the train underscore test underscore split, the train test split, and you're going to pass in here our x and our y. Before we do that, let's create another cell above here and select our x. So our x will just be the target, the independent variable, I mean the dependent variables, right? And then the y will be the dependent variable. Okay, so the x will just be a df. We're going to drop something. It is going to drop the target column, the drop, and then you're going to pass in here target, and then you're going to specify which axis. So we're going to say axis just be 1, and then yeah, just like that. Yeah, we can just run that cell, and then we have split. Now let's go and do the one for the y. So the y will just be a df, and then you're going to get the target column. Okay, so make sure I get the spelling right. So target, and then right there. So now we can go ahead and actually check out y, and then we can have that target there, and then we can check out x, and then we have that right there. So now we can pass in here, we're going to pass in our x and then our y, and then we're going to say train underscore size. We're going to use 80% for training, so we're going to say 0.8, and let's set the random underscore state to just be 200. Okay, so now we have done that. We can run this, and then we'll have our x train, our x train. If we go x train, we can have that data set, and we can check its shape. Okay, so we can do dot shape, and then we can run that. So it is 224 columns. So, and then we can do x underscore train. So this will be test dot shape. So we can run that, and then it's just 61. So now that we have our training and testing data set, let's go ahead and actually create our model. So to create our model, we are going to import this from ensemble. So whenever you're having with different models, and then you want to concatenate their result or do bugging, you're going to use the ensemble. You're going to import from the ensemble. So we're going to do from, sorry, I'm going to close this up, and then you're going to say that from Sklearn dot ensemble, okay, spelling right, ensemble import random forest. This is forest classifier, just like that. You're going to import the random forest classifier. So I'm going to call it run. I'm going to call it run 4, and then this is just going to be an instance of my random forest classifier. So I'm going to go random forest, and then classifier, just like that, and then we can run that. So this is going to create for us our model. So now we need to train our model. So we're going to run for dot fit. We're going to fit. You're going to pass in our x underscore train, and then you're going to pass in y underscore train. Okay, y x train, and then the y train. We're going to fit our model, and then we have that model there. So before we can do this, I have told you about the number of trees, right? You can specify the number of trees. So you can just press moving into this parenthesis, and then you can press shift and tab on your keyboard. Just shift and tab, and then you can bring up that documentation, and then you can read some things that you can pass in. So I'm just going to make this larger. Okay, try to make this larger. Okay, so now we can see what we can pass in here. So we can pass in, it doesn't give much documentation, but let me just close this, go back to the official documentation. You can see in the official documentation, it tells us like you have created a random forest classifier, and then we can pass in some the number of trees that we want. So we can it's actually called let me scroll up here. I've seen it somewhere. Let's scroll here up. Let me just search for it. It's not number of samples, it's number of features. Yeah, it's number of the estimators right here. So we can pass in the number of estimators. By default is 10. So the number of estimators are the number of trees, decision trees that will exist within your random forest. Okay, so I'm just going to copy this from here, and then I'm going to move it from here, and then I'm simply going to paste it in here. We can specify the number of, let's say we want 20 decision trees. Okay, this will take a longer time to train, but let's just go for 20, and then we got the number of estimators. We got it wrong. There's a trend does not, okay, I think we need to pass it not in here, sorry, my bad. You need to pass this in here, so pass that in, and then we can, I got an error, so why? Okay, I didn't copy that right. Run this, and then we can make sure I also run this. So now we have a number of estimators to be 20. Okay, so now we're going to have 20 individual decision trees within our random forest. Okay, so our forest of decision trees has 20 trees. Okay, be careful not to really bring these numbers up. It can really take a lot of time to train and stuff like that. Random, so let's go random forest, and if you have already fit, you can do we can go ahead and actually do the predictions and stuff like that. So we can just store it in a predictions, and then we can do run for, and then we can dot predict. Let me pass in here dot predict. Predict, and I'm going to pass in x underscore test. We're going to predict for x test, and then we can run, and then go ahead and actually print the predictions. Sorry, predictions. Okay, and I can run print out the predictions, and then let's wait for it doesn't return anything. I don't know why it does not output anything. Why I've converted this to be code. Okay, let me just try to run this. Okay, that was the problem. So predictions. So my problem is I press the key and it changed this to be other thing rather than code. So predictions, and then I'm simply going to write. So we have all those predictions right there. Okay, so now that we have that, we can go ahead and actually begin to evaluate our model and stuff like that. So before let me just evaluate it from first, and then we'll see other things. So we're going to do from sklearn dot matrix import. We're going to import the classification underscore report. Just import that there. So we're going to import the classification report, and we're also going to import confusion matrix. Okay, we have those two imported. So let's go ahead and actually get the classification report. So I'm going to print this off for proper formatting, classification underscore report, and then report, and then in here you're going to pass in our true value, which will be the y, our predictions, and then our true value, right? So we're going to pass in the predictions and then the truth value. So the prediction just be predictions, and then this will just be the y underscore test, right? So we run that, and you can see our model is actually has a good accuracy of 79% accuracy and stuff like that. So in here you're going to pass in, sorry, you're going to pass in, I made a mistake, you're going to pass in the truth value and then the prediction. Okay, so like this, and then I remove this here, and then I run it. So our model has a 78% accuracy. Okay, so now that we have that, let me just check this, make sure I didn't forget that thing. So we need to pass in the truth and then the prediction. Yeah, so that's right. So these are the truth values, and then these are the predictions. Okay, so we have 78% accuracy. Now we can do better than this. One of the ways that we can improve our model performance is actually by scaling this data. So we can import the min max scaler, and then we can scale all these huge values, and then our model can do much better. But for now, let's go ahead and actually print the confusion matrix. So I'm going to go confusion, create a confusion matrix equals to confusion matrix that we have just imported, confusion underscore matrix, and then in here I'm going to pass in the x train. I'm going to pass in I'm going to pass in the truth value, which is just the y test, and then the predictions, right? The predictions which we just got, which are the predictions, and then y test. Make sure I get the spelling right. So we have predictions, and we can do our cn. We have our confusion matrix there. So let's import cbon as SNS. So we're going to import cbon dot map. I hope by now most of us we are used to this, right? We have been doing this since the beginning of the series, right? So we're going to create a heat map in here to visualize our confusion matrix. So we're going to pass in our confusion matrix, and we're going to say a not equals to true, so that we can be able to see those values. So we can run this, and then this will go ahead and actually create for us the confusion matrix, and this is the confusion matrix that we have. So we can import cbum, import matplotlib, and then make this larger. So we're going to import matplotlib dot pyplot as plt, and then up here you're going to make a figure, and then give the figure a size so that we can have this bigger. So we're going to go plt dot figure, and then you're going to pass in fig size, and this will just be a tuple. We're going to pass in 12 by 7, and then down here we're going to go plt.show. So we're going to do a plt.show, and then I'm going to run that there. We can see we have that big figure, so we can go ahead and actually say this one here will be the yeah guys. So that's all I wanted us to discuss in this tutorial. So you can see our model is actually doing just fine. So that's how you can create a simple decision tree using Sklearn. You can see that our model, we can actually get a bigger accuracy than this. So that's what I'm going to assign you with. The problem is that we can get accuracy by making this to be scaling these values. Like for example, these age values which are just too large, we can scale all of this to using the min max scaler. Okay, so you can just go on the line, and then you can search Sklearn min max scaler, and then try to scale these values, and then before training your model, this will give your model better accuracy. So this is my assignment for you. Do it, and then if you get an accuracy above 85, please leave it in the comment section below. Yeah, the winner, anyone who can reach an accuracy of 90 will be the winner. So thanks for watching. If you like this tutorial, again, give this video a thumbs up and subscribe to my channel for more videos like this. So thanks for watching. I'll see you in the next tutorial. Keep safe.